So you've had your opportunity as an individual, you've had your opportunity with teammates. So now let's see how we can put this all together to have a working proof. So first, look at your proof and please hold up the number of fingers representing the number of statements that are in your proof. I will hold up the number of mine. And now keep your hands up and look around. Good, put your hands down. Now look at the reason for your very last statement. Take your index finger and point, put it actually on the reason for the very last statement. Take your index finger. Good, Ziamara, what is the reason? Okay, Kadir, what was your reason? Okay, Dayanara, what is your reason? Success. Okay. So, here is my proof, and of course there's more than one way to prove it. I already indicated that I had 6 statements. I have given in 3 different statements. I could have condensed that into 1 and gotten the whole thing down to 4 statements if I really wanted to, but I wanted you to be able to see the second statement comes from the first. 4th statement comes from the 3rd, and then the 6th statement comes from all of it put together. So, this proof today required you to reach back to skills you learned in previous chapters. Let's answer a simple question, and let me erase part of my picture to do it. I need someone working at the high level that I expect. These 2 lines are parallel as indicated by the arrows and indicated up here. What is this line called in relation to the parallel lines? It has a name. Everybody in the room should know the name. What is its name? Stephanie? That is a transversal. And when you have 2 parallel lines cut by a transversal, a whole bunch of angle relationships pops up. Could someone tell us what is the relationship called between that angle and that angle when you have parallel lines cut by a transversal? Everybody in the room should know it. I'm not saying everybody in the room does know it. I'm saying everybody in the room should know it. So if you're sitting there and you're saying, I don't know what it's called, that's a problem. Because everybody in my room is going to do this. And to do this, you have to know this as if it's no big deal. Nathaniel? Those are called corresponding angles. Now, if the 2 lines are parallel, cut by a transversal, and you have corresponding angles, then you can say that the corresponding angles are, now fill in the last word. They are what, Sharik? Congruent. They are congruent. And so we use the knowledge of the parallel lines to help prove that those 2 angles are congruent. And so we have shown this. Now let me do the same thing again by focusing on a different part of the picture. And I even heard a couple of students talking about, I really like the way someone said, pull apart the picture. You have to pull apart the picture to see the important pieces of information. So now we have a different pair of parallel lines cut by the same transversal, and now we have this angle and this angle. Nathaniel, the relationship between those 2 is? And Sharik, corresponding angles are if we have parallel lines. So now we can say this. So I have this here, and I have angle, side, angle. And that's the evidence that I laid out. I can highlight each of my key pieces of evidence. I can highlight key piece of evidence right here, key piece of evidence right here, key piece of evidence right here, and that allows me to say that I have proven my case. Dayanara, you said you used side, side, side. How did you go about doing that? Definition of a parallel line says what? It's wrong. The definition of a parallel line says it's wrong. Oh, you're saying that your idea was wrong. Okay. What is the definition of parallel lines? Okay, so we're a little confused about that. That's fair. And you're not the only person. A lot of people look at these marks here and here, and because the lines look like they're the same, automatically assume that they are the same. But these marks do not indicate congruence, they indicate parallel. So you have to be careful with that. Dayanar, there may be a way to prove this using side, 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 but I would have to work on it for a while. I'm not sure if it's possible, but it might be. But I hope you can see now that angle, side, angle, it was a much more efficient way to go. Not necessarily easier, more efficient. Any questions? Any concerns? Okay. Today's lesson is lesson 4.7. You already titled your paper that. And today we're going to use congruent triangles. We've been developing this idea, this ability to prove two triangles congruent to each other. Now we're going to start doing something after we prove them congruent. So, our objectives are using congruent triangles to prove other things. So I want to show you something from a previous lesson, not for you to copy down. I want you to look. This says lesson 4.7, use congruent triangles. I copied this from a previous lesson. Notice it says lesson 4.2. So a lesson 5 lessons ago that we should be level 7, 8, or 9 with our understanding. This is where we established the idea of congruent polygons, and specifically congruent triangles. And so we had the definition of congruent polygons, and we used triangles specifically, right here. Two polygons, or two triangles, are congruent polygons, or congruent triangles, if and only if their corresponding sides are congruent. And in fact, once we established that two triangles were congruent, like here, then we were able to say all sorts of different things about those two objects. So if we can prove two triangles are congruent to each other, then we're allowed to pick out the parts. Excuse me. We're now allowed to say things about corresponding parts. And so the word corresponding, really important here. Okay? So we just proved here that the two triangles are congruent. Dayanara wanted to say something about this side and this side. Dayanara, what can you now say about those two sides? They are congruent. Why? Because we proved by this that the two triangles are congruent. Now we can say that ZV is congruent to XU. Now we can say VY is congruent to UW. Because of the definition of congruent triangles, we can now say those things. And that's what we're going to work on today. Any questions about that? So let's jump in and start working. So, using congruent triangles. read the instructions, but you don't have to copy them. Make sure you put example 1A because there's going to be a part B. Now, we want to be able to say that this is true. I want to prove that this angle is congruent to that one. But what I want to do first is I want to prove the two triangles are congruent to each other. Once I accomplish that, then I can very simply say these two corresponding angles are congruent. So first we have to prove the triangle's congruent, and now you are an expert at that. You now have an entire toolbox of techniques. So let's review the toolbox briefly. Can someone give me one way to prove triangles congruent? One way. Stephen? ASA, there's one. Give me another way to prove it. Kamoy? SSS, give me another way to prove it. Stephanie? SAS, give me another way to prove it. John? Hypotenuse leg, give me another way to prove it. That's 4, we're missing one. You should know them all off the top of your head. Alexandra? AAS. We have 5 different techniques at our disposal. Plus, we have all sorts of other ideas like vertical angles and corresponding angles like Nathaniel pointed out. Alternate interior angles, alternate exterior angles. We have all these different ideas that we can use to help us use HL, ASA, SSS, SAS, and so on. So now our job is to tap into the toolbox to figure out what's the best way to go about this. So, which triangles can you show to be congruent so that we can say this, and what postulate or theorem would you use to prove the triangles are congruent? Yes, this is an example that I'm using to model, but we are going to make the examples interactive today. And you're going to take 1 minute with your team, and you are going to come up with one postulate or theorem or idea that you can use to prove these two triangles are congruent. Be ready to say, anyone on the team needs to be ready to say what idea you think will prove them. Go. Okay, give me a thumbs up if you and your team was able to come up with a postulate or theorem that you could use. Okay? Good, put your thumbs down. Kayla, what'd you guys come up with? Okay, Ziamara, what did your team come up with? Same thing. Stephanie, what did your team come up with? Angle, side. Okay. I would agree with that we've got, it's a little hard to see initially, but we got angle, angle, side, and then the other triangle, angle, angle, side. So we can use angle, angle, side, and we don't have to write out a whole proof, but we know that we have the evidence to support that. So we can use angle, angle, side, okay? So let's write that down, that we're going to use angle, angle, side, congruence postulate to prove the two triangles are congruent. But now, we need to write a congruent statement. It says, tell which triangles you can show are congruent. So I'm going to write the first part, and then you guys are going to take 20 seconds to fill in the second part. Triangle HGL. Triangle HGL is congruent to triangle, and now you fill in the next three letters, remembering that the order of the letters matters. So go ahead and fill in the next three letters and see if you can figure out the right order. I'm going to fix my triangle because I'm not happy with it. Now check with your teammates to see if you got the same letters, same order. Okay, so what should the order be? Where's my confidence? Valor? Rate your confidence from 1 to 10, 10 being the most confident. 10? Yeah, absolutely, it's JKM. And that is the only way to make the statement if I put HDL. If I had written the first triangle differently, then I could rewrite the second triangle differently. But the order matters. Angle H, it corresponds to angle J. Angle G corresponds to angle K, and angle L corresponds to angle M. So that congruent statement has to be that way. So these are two things that we are asked for. Which triangles and what postulate? Both. Any questions about that? So now the point. The point is we can now say this. We can now say that that is congruent to that because we did our job proving the two triangles are congruent to each other. This was our goal, and we accomplished it. Any questions about that? Okay, let's go to part B. You don't have to rewrite the whole example 1. You can just write part B. The instructions are exactly the same, but I have a new set of objects that I would like to prove congruent. I would like to prove segment BC is congruent to segment AD. I'd like to be able to do this, but I don't know if I can. So the easiest thing to do is to prove that this triangle is congruent to this one. If I can show the two triangles are congruent to each other, then I can say the parts are congruent to each other. So that's what we would like to accomplish. So I'm going to give you another minute of team talk. And you need to come up with a way of proving these two triangles are congruent to each other. You got 1 minute. Go. Try not to look at your cheat sheet if possible. Try to do it without looking. Okay, give me a thumbs up if you and your teammates were able to come up with a reason, a way to prove. Okay, some Looks like most of you put your thumbs down. All right. Valerie, what did your team come up with? Side, angle, side. John, what did your team come up with? Side, angle, side. You agree with them? Okay. Do we already have all the evidence that we need to say that? We want to use side, angle, side, congruence postulate. Is all the evidence already in the diagram? Okay, so someone tell me what you think. Kamoy, what do you think? Okay, so there are two pieces of evidence marked. We have side and angle, but we're missing the third side. So we have to establish that segment AC is congruent to itself by the reflexive property. So we would have one step, then we would have side, angle, side congruence postulate. And then, because we proved the two triangles are congruent, then we can make this statement. But before that, we need a congruent statement. So now this time, you are going to do the whole thing. I am not going to start you out. So I want you to make a congruent statement for the two triangles, making sure that you get the letters correct. So take 20 seconds to do that and compare what you wrote with your teammates. Go. All right, what's your congruent statement? Read me your whole congruent statement with some confidence. Got 3, 4 confident people. I'm going to the equity bars next time. Steven? Triangle BCA is congruent to DAC. BCA, DAC. Looks right to me. Angle B corresponds to angle D, angle C corresponds to angle A in the other triangle. Yeah, that works for me. Mine was different. I did BAC and then DCA, but it doesn't matter as long as you got the order right. So now that we have proven this, now we can say that that is true. Now we could add this to the diagram if we wanted to. Anyone have any comments or questions on what have we been doing, our objective? Any comments or questions? Okay, now try it out on your own. Now I want you to do everything. I want you to tell me what postulate or theorem you would use to prove the triangles are congruent. Then make a congruent statement, and then you would be able to say that is true. So you got 2 minutes on the clock. I'll move out of the way in a moment. Go. All right, let's see what we came up with. You're going to first give me the reason that the two triangles are congruent. To the equity bars I go. I've got student number 3, student number 4, student number 13, and student number 9. Student number 3, what did you say? Student number 4, what did you say? Student number 13, what do you say? And student number 9, what do you say? You all agree that we could use SSS. I would agree with that. And here's the congruent statement that I wrote. I wrote ABD is congruent to CDB. If you have a different congruent statement, that's fine as long as the letters match up. A and C have to be in the same position, B and D have to be in the same position, and D and B have to be in the same position. So you could reorder it, but everything has to match up. Is anyone unsure if theirs is correct? You can raise your hand and we'll check. Okay, give me a thumbs up if you got the checkpoint correct. Good, put your thumbs down. Any comments or questions? All right, I set something up and then I'm going to modify it. This was example 2, but it's pretty time consuming and involved, and it's actually interesting, and we're going to do it interactively. But there's some other things that I have to go over with you, and if we don't, we're going to not be able to function with doing our homework and quizzes. So what I'm going to do is I'm going to table this one for at the end. And I'm actually going to go straight into another checkpoint. And this is the checkpoint. Don't write anything yet because I want to talk about something. You're going to do checkpoint number 2, and you're going to write an actual proof. All the given is in the diagram. Here is your prove statement. I want to remind you that prove statements are the last thing that you write in the proof. So let me reflect on the warm-up today. That here was the prove statement, and again, there it is, the last statement. But this time, the prove statement is not two triangles congruent to each other. This time, I'm looking for a segment congruent to another segment. But you're going to prove the triangle's congruent first, and then make that statement. So in actuality, this proof might look similar to this one, except this is the second to last statement. Then you have another statement underneath this one that is the proof statement. So your second to last statement might be about two triangles being congruent because of some reason, and then you might have another statement that's a congruent statement for two objects, and the reason would be corresponding parts of congruent triangles. So that's what we're working on. That's what we've been working on so far today. Okay? Any questions about that? So, checkpoint number 2, prove that segment DB is congruent to segment CB. I'm looking for a full proof, so I'll give you 4 minutes on the clock. You might want to draw the diagram to help you out. You don't need to use your ruler, you can just sketch it. Of course, you're having trouble. Yes, try first on your own. Try without looking at your cheat sheet on your own. Then look at your cheat sheet. Still not working? Then ask a teammate. Still not working? Then ask me. make sure everyone's had enough time to work through it. Give me a thumbs up if you have a full working proof. Okay, good. Put your thumbs down. That's most of us, so we're going to proceed. If you're still trying to finish it up, go ahead and rapidly try and finish your proof. Here is my proof. And again, this is not the only way to do it. This is one way to do it. I had 5 statements. I could have condensed it down into 4. We already knew what the last statement was going to be because that's the prove statement. First, we needed to prove the triangle's congruent. I immediately saw that I had an angle and a side, and jumping out at you should have been this right here. Should have been jumping out at you. Vertical angles, vertical angles. I am an expert at vertical angles. And now we can say that the 2 triangles are congruent to each other because of angle, angle, side. But now your congruent statement has to be correct. So angle C and D have to match. Angle B and B have to match, and angle E and A have to match. So make sure you've got that matched up right. Once you establish this statement right here, then you can say anything you want about the 2 triangles. You can say this is congruent to this, and you can say this is congruent to this. I asked you to show this. So that is the last statement. Anyone have any questions or comments about what we just did? Give me a thumbs. Yes, Kadir.
So like, with number 5, can you also say definition of congruent triangle?
That's fine. Definition of congruent triangles, sure. So give me a thumbs up if you had a valid proof. Okay, now look at the rubric and give yourself a score on it. If you're telling me it's a full valid proof, it should be 4. If you think you left out a statement, give yourself a 3. If you just wrote the given statements, then unfortunately you get a 0. Any comments, questions? Okay. So now we're going to shift gears a little bit. We're still using the same ideas, but we're going to shift in the perspective that we're using. So, first, example 3, read the question to yourself, and then we'll digest it, and we'll figure out what to do. So, we are asked to prove this. We have no picture, and we are given all of this. Just to make sure we're understanding, it says the vertices of triangle ABC. So these are the corners, the vertices of triangle ABC. Then we are given triangle DEF. Here are the vertices for DEF. We have to somehow prove angle C is congruent to angle F from that information. So you got 1 minute with your team to come up with some way of doing it. Come up with something. Some idea.
We're gonna have to grab it. Can we do like side, side, side? And then the side.
All right, what'd you come up with? John, what'd you guys come up with? They're not congruent? So if you're saying we should draw a picture. I was asking you to come up with a method to show that angle C was congruent to angle F, and you're saying that they're not. But you have to be able to prove that they're not. I'm sorry? Okay, so you already drew a picture? Okay, so you drew a picture of the information, and you're saying they're clearly not congruent. Okay, I apologize for the interruption. So it doesn't matter whether in the world of law, if you want to prove a client guilty or you want to prove the client not guilty, you have to have evidence either way. So if John wants to say that angle C is not congruent to angle F, then he has to be able to prove it. Sharik and then Kamoy.
We can use SSS since we're given the coordinates of the vertices
And so if we were able to say SSS, then the two triangles would be congruent, and then because they were congruent, then we could say angle C was congruent to angle F. Because if you're paying attention, angle C and angle F are corresponding. So if we can prove these two triangles are congruent to each other, then we can make that statement, and you're suggesting SSS. Kamoy and then Kadir. I apologize, he stole your thunder. Kadir. Okay, so now we're starting to build an idea, an approach. He wants to use, or that team wants to use SSS, but we don't have a picture. And we don't have something that has tick marks on it or arc marks on it. We're given coordinates. So in this case, we're faced with a mathematical approach. And that is a very good and a very effective approach, and that is actually what we were kind of gearing towards. Unfortunately, it's not the most pleasant. It's quite a bit of grunt work. But I promise you that as you do it more and more, it gets easier and easier. For this example, I'm going to divide up the workload. So make sure you're paying attention. We have to prove sides are congruent to sides, corresponding sides are congruent. So what's the first side in this triangle? AB. What's the first side in this triangle? DE. So we need the distance of AB and we need the distance of DE. So everyone's going to follow along with me. AB, notice I did not put a bar across it because that's a distance. Using the distance formula, the difference of the x's plus the difference of the y's will get me that distance. And then if I can show that that's the same as DE, if I can show that those are the same, then we've got corresponding sides congruent to each other. everyone in this first row, from Kadir all the way to Kayla, you will be in charge of showing this to be true. Don't start yet, please. Follow along with me because you also have to do the other parts, but your classmates are going to help you. Could someone tell us what's the next side in the triangle? What's the next side? Nathaniel? We could say it doesn't really matter. So BC would be the next side. I'm going to leave a little space here. If I were you, I would leave a line of space. BC is also going to equal the difference of the x's squared plus the differences of the y squared. But we want to show that BC is the same distance as EF. So we've got EF. Everyone in the second row, from Stephanie all the way across to Extol, will be in charge of BC and EF and showing whether or not they are the same. And then finally, what would the last side be in that triangle? We got AB and we got BC. What's the last side? Kamoy? That's right. We go first letter to the last letter. So now we've got AC. And then she already gave us DF. And so everyone in the last row, from Dayanara all the way to Kamoy, will be in charge of AC and DF. Okay? So now, use your calculators, use your mental math powers, and go ahead and figure out the distances that you were in charge of. And you're going to help me because I don't know the answers. So, I don't know, it should take you what? A minute to figure out both of them? Since everybody's got just one part. And I'll start filling in some stuff as well. Let's see if I can do some of this mentally. Difference of the x's, 0. Differences of the y's,
Square root.
2. All right. Give me a thumbs up if you got both your values that you were trying to find. You got both of them? Okay. Alexandra, you were in charge of A, B, and D, E. What'd you get for A, B? What's the square root of 4? 2. Okay. Kayla, what'd you get for D, E? 2. So we see that these two sides match. These two sides match. Okay? What about my second row, BC and EF? What'd you come up with? Stephanie, what'd you come up with for BC? Let's see, square root of 5, yeah, and we don't need, that's not a nice perfect square. And so what about EF? Extol, what'd you get for EF? Square root of, is it square root of 10? Did I make a mistake? It's quite possible. Stephen, did I make a mistake? You got square root of 10? That's 9. So I messed up something. I did, this was EF. -3, minus 0 is -3, -1, minus 1 is -2. I don't think I messed up. Zumara, what do you think? It's the square root of 13. Okay. Sorry guys, you had the right idea, but you messed up on some computation. So what did we just figure out right now? What did we figure out? What's not congruent? So what, okay, go a step further. What can we say about these two triangles? You don't know? Okay. That's fair. You raised your hand. I called on you.
I thought it was just not congruent.
Okay. Well, something just happened. What just happened? So just the same 4 or 5 people can recognize what happened. I appreciate Alexander trying. Kamoy, what just happened? And so what can we say about the two triangles? Yeah, the triangles are not congruent, clearly. This and this is not going to be the same value, so unfortunately, the lengths are not the same, and so we cannot say that they're congruent, and so we cannot say that these two are congruent angles. But we have evidence to support that. This shows it. Well, just because we showed that, let's finish it out anyway. Because I had a team who did A, C, and DF. What'd you get for AC? Valerie, what'd you get for AC? Square root of 5. And what about DF? Dianara, what'd you get for DF? Square root of 5. So those sides were congruent to each other. These two corresponding sides were congruent. But the hiccup is right here. This and this, not the same length. And so the two triangles are not congruent. And so angle C is not necessarily congruent to angle F. Any questions about how we did that? So it is a little uncomfortable. There's a lot of grunt work. That's an incredible amount of work. Be careful with your mental math. Some of my students, I gave you 1/3 of the work and you made a mistake. Now I'm going to give you all the work. But I will let you do it as a team. So you have 3 people on your team. Organize yourselves. And I would like you to show me that in this scenario, that angle C is congruent to angle F by first proving the two triangles are congruent. Yes, I use the same letters, but this is not the same set of information. So go ahead and organize yourselves, and as a team come to a conclusion. You've got, let's say, 3 minutes. Did you have enough time to come to a conclusion?
Yes.
Shake your head, give me a thumbs up, something. You're done?
Foursquare.
Okay. Well, I can't quite tell, but it seems like most of you were able to come up to a conclusion. What conclusion did you come to? Angle C congruent to angle F or not? Nathaniel, what did your team come up with? Okay. How did you prove it? Well, you sum it up. And how do we say that? There you go. Triangles are congruent by SSS, therefore, angle C is congruent to angle F. So in this case, the corresponding sides had the same distances, it all matched up. Any comments, questions about that? Comments, questions? And I wrote checkpoint number 2. This is supposed to be checkpoint number 3, so I apologize for that. 3. Okay, so unfortunately for you, that we split up the workload of this challenging kind of grunt work situation. We split it up as a whole group, as a whole class, and then I let you split up the workload as a team. When you have questions in your homework, you have to do it by yourself. The good news is I only gave you 1 or 2 of them. Okay? So draw a line across your paper. Your homework is on page 259. You're going to do numbers 3 through 11 and 13 through 22, and then number 23 is a 4-point proof. Make sure you grade it appropriately and give yourself a number of points from 0 to 4. And that will be a total of 23 points for the assignment. Do the at-home tutor for the next lesson or read the section of the next lesson. And you will have a quiz on Friday that will go from 4.5 to 4.8.